In our last video, we learned how to add fractions. Today, we're going to learn how to subtract fractions. It is pretty much the same method as adding fractions. But remember, fractions can be added or subtracted only if they have the same denominator. So you're going to have to remember that again for today. The first question we're going to look at is over here. We're going to be looking at question A, which is find the difference between 3 over 4 and 1 over 3. In other words, 3 over 4 subtract 1 over 3. So in this question, we want to have 3 over 4 subtract 1 over 3. The first thing you'll notice is that the denominators are not the same, but we want them to be the same. Therefore, we're going to have to find the lowest common multiple of 3 and 4. I'm going to go ahead and list some of the multiples of 3 and 4. So 3, 6, 9, 12, 15. I'm going to stop there. I'm going to do the multiples of 4, 4, 8, 12, 16. I'm going to stop there. Immediately, you'll notice that there's a common number, and that common number is 12. So I'm just going to label 12 is the LCM. The next step is to write equivalent fractions. I'm going to write an equivalent fraction for 3 over 4, as well as our other fraction, 1 over 3. We know that the new denominator is going to be 12. So you have to ask yourself, how do I go from 4 to 12? You multiply that by 3. What you do to the bottom, you have to do to the top. So you're also going to multiply that by 3. 3 times 3 is 9. I'm going to do the exact same thing on the right. The new denominator is going to be 12. How do I go from 3 to 12? Well, you actually multiply that by 4. What you do to the bottom, you have to do to the top. So I'm also going to multiply that by 4. And 1 times 4 is actually 4. I'm going to rewrite my question using the equivalent fractions I just figured out. So we have 9 over 12, subtract 4 over 12. Because the denominators are the same, we can go ahead and subtract these fractions. So I'm going to look at the numerators. 9 subtract 4 is 5. And the denominators stay the same, so it remains 12. Do not make the common mistake of subtracting 12 by 12, which is 0. Don't do that. Before we finish, we have to ask yourself, is this fraction reduced? Is it in its lowest terms? To do that, we have to find the greatest common factor of both 5 and 12. The factors of 5 are 1 and 5, since it's a prime number. The factors of 12 are 1, 2, 3, 4, 6, and 12. As you can see, the greatest common factor here is 1. So if we divide 5 by 1 and 12 by 1, it remains exactly the same. So our final answer actually is 5 over 12. In our next question, we're going to be looking at 3 and 2 over 5 subtract 2 and 1 over 4. You might notice this question is very different from previous questions we've done. These are actually both considered mixed numbers. Why are they considered mixed numbers? Well, they are a mix of integers and fractions. I want to convert these mixed numbers into improper fractions. If you recall, an improper fraction has a numerator which is greater than its denominator. I'm going to show you how to convert 3 and 2 over 5 into an improper fraction. What you want to do is you want to take the 3 and multiply it by 5. 3 times 5. Then afterwards, you're going to add 2 to it. The denominator remains the same, remains 5. So all you have to do now is you want to follow simple BEDMAS. So you want to do your multiplication first. 3 times 5 is 15. 15 plus 2 over 5. I'm just showing you all the steps. Afterwards, you're going to do your addition. 15 plus 2 is 17, and the 5 stays the same. So what we've done there is we've just converted our mixed number of 3 and 2 over 5 into 17 over 5. It's going to convert our other mixed number, which was 2 and 1 over 4, into an improper fraction. So what you're going to do is you're going to take 2 times 4, and then you're going to add 1 to that. The denominator stays the same, so it remains 4. We're going to do some bed mass here. We want to do multiplication first, so 2 times 4 is 8. 8 plus 1 over 4. We're going to add 8 plus 1, which is 9, which gives us 9 over 4. So what we've done is we've just converted our mixed numbers into improper fractions, which I've just circled. I'm going to rewrite this equation with the improper fractions we've just figured out. So I have 17 over 5 subtract 9 over 4. Just like before, you'll notice that the denominators are not the same, but they need to be the same before you can subtract these fractions. We need to figure out the lowest common multiple of both 4 and 5. I've listed out the multiples of both 4 and 5, and as you can see, the lowest common multiple happens to be 20. We're going to write equivalent fractions for 17 over 5 and 9 over 4. So let's make some space. So I have 17 over 5 and I have 9 over 4. Now I want you to take a look at the stuff on the left. The new denominator is going to be 20. How do I go from 5 to 20? You multiply by 4. What you do to the bottom, you also have to do to the top. If you're not sure how to do this in your head, you can go ahead and use a calculator. 17 times 4 actually is 68. Now I want you to take a look at the stuff on the right. The new denominator here is going to be 20. How do I go from 4 to 20? You multiply by 5. What you do to the bottom, you also have to do to the top. So 9 times 5 actually is 45. So what we've done is we've just written equivalent fractions for 17 over 5 and 9 over 4. I'm just going to move this up to make a little bit more space, and I'm going to rewrite the question with our equivalent fractions. So we have 68 over 20 subtract 45 over 20. Immediately you'll notice that the denominators are the same. So we can go ahead and subtract these fractions. We're going to take a look at the numerators. 68 subtract 45 is 23. If you can't do that in your head, you can go ahead and use a calculator. Remember, the denominators stay the same. So the denominator is going to remain 20. Do not subtract them. That would be incorrect. At this point, you should realize that our answer here, 23 over 20, is actually an improper fraction because the numerator is greater than the denominator. So we're going to go ahead and convert that into a mixed number. So remember, fractions are just division. What we're actually doing is we're going to divide 23 by 20. So 20 goes into 23 once. 1 times 20 is 20. We're going to find the difference between these two numbers, which gives us 3. So a remainder of 3. Now, that number is actually going to be the integer. The remainder is going to be the numerator. And that number over here is going to be the denominator. And the very final step is to ask yourself, is this fraction reduced? Well, the factors of 3 are 1 and 3 since it's a prime number. Both 3 and 20 are divisible by 1, but 20 is not divisible by 3. Therefore, this actually is our final answer. We're going to be doing one last example. We want to figure out 2 and 2 over 5 subtract 1 and 1 over 3. You'll notice that these are both what we call mixed numbers. We want to convert these mixed numbers into improper fractions. We're going to first take a look at 2 and 2 over 5. So we're going to take 2, multiply it by 5, plus 2. The denominator stays the same. Remember, you want to use your BEDMAS. 2 times 5 is 10, plus 2 over 5. 10 plus 2 is 12, and the denominator stays the same. Okay, now we're going to take a look at the other fraction, which is 1 and 1 over 3. So again, we're going to take 1 multiplied by 3, add 1 to it, and the denominator is going to stay the same. It's going to remain 3. You want to use your BEDMAS here. I'm just going to move that to make some space. So 1 times 3 is 3, plus 1 over 3. Now you want to go 3 plus 1, which is 4, and the denominator stays the same. So what we've done is we've just converted our mixed numbers into improper fractions. Let's go ahead and rewrite our question with these improper fractions. So we actually have 12 over 5 subtract 4 over 3. And you should notice that the denominators are not the same. They have to be before we can add or subtract fractions. So we want to find the lowest common multiple of 5 and 3. I'm going to quickly list out the multiples of 3. 3, 6, 9, 12, 15. I'm going to stop there. I'm going to list the multiples of 5. 5, 10, 15. I'm going to stop there because I noticed that we have a common multiple, and this is 15. I'm going to write equivalent fractions for the improper fractions I figured out earlier. So we have 12 over 5 and 4 over 3. Now the new denominator is going to be 15. So how do I go from 5 to 15? You multiply by 3. What you do to the bottom, you got to do to the top. So 12 times 3 is 36. I'm going to do the same thing to the stuff on the right. The new denominator is going to be 15. So how do I go from 3 to 15? You multiply by 5. What you do to the bottom, you also have to do to the top. So I'm also going to multiply that by 5. 4 times 5 is 20. So what we've done is we've just found equivalent fractions for 12 over 5 and 4 over 3. I'm going to rewrite our original question with these equivalent fractions. So 36 over 15 subtract 20 over 15. You should notice that the denominators are the same, so we can go ahead and subtract these fractions. Let's make a little bit of space first. So 36 subtract 20 is actually 16. The denominators stay the same. Do not touch them, do not subtract them. That would be incorrect. You should notice right off the bat that 16 over 15 actually is an improper fraction since the numerator is greater than the denominator. So what we're going to do is we're going to take 16 and we're going to divide it by 15. So 15 goes into 16 once. 1 times 15 is 15. We're going to find the difference, and the difference is 1, which leaves us a remainder of 1. So the 1 up here is going to be the integer. The remainder down here actually is going to be the new numerator, and the 15 over here is going to be the denominator. And our final answer is 1 and 1 over 15.